Holy moly! Hello everybody. Welcome back to another mathematics lesson. So in this case, we are going to be dealing with equations and fractions. Oh my goodness, we really don't like fractions and now we have to do equations. Are you serious? Why are we here? Well, fear not. This stuff is the easiest thing that ever existed with this video. So don't worry. First things first, right? We need to recall something from fractions, right? Clearly, what we are trying to do is we are trying to get rid of these fractions. We are trying to find a way to get rid of them. And there are steps to these, right? First things first, the first step is to make sure that everything is a fraction, okay? Such that we are able to write an entire fraction on one side and one fraction on another side. So you can see clearly there's actually two terms here, but we want to write that whole thing as one fraction, okay? And then from there, we can get rid of some denominators and blah, blah, blah. So let's start with the first step, okay? And we'll do another example. We'll only be doing 2 examples for this video. So the first example, we'll obviously get the hang of it, use the steps that we are going to get used to. Then the next example, we're going to do the exact same thing, but with a typically challenging question, if you will. So let's do this. First things first, right? If I were to tell you the following, if I were to say 3 minus 4 over 5, how would we write down the whole thing as one fraction? We'll take note that here, this is a whole number and this is a fraction. And in order for us to write two things as one fraction, we need the same denominator. So notice 3 can be written as 3 over 1, but 1 is not the same as 5. So if you remember an operation in fractions is that we'll have this, it'll look something like this, right? What you do on the bottom, you'll do on the top. So you want this 1 to turn into 5, and how do you do that? By multiplying by 5. So if you multiply the denominator by 5, you'll also multiply the numerator by 5. Therefore, what this gives us is 3 times 5, which is just equal to 15 over 5, minus 4 over 5, and that is where we have the same denominator. And remember, in one of the videos, if you checked it out, rule 3 is when we have the same denominator, we can now write it as one fraction, so over 5, but the numerators will go into the same numerator in that one fraction, keeping the same operation, which is subtraction, or addition if it's another case. So this will be 15 minus 4, if that makes sense. And then 15 minus 4 will just be 11, and therefore the answer should be 11 over 5. Okay, you can verify that in your calculator from just taking 3 minus 4 over 5. Okay, so let's use that exact same operation here. The lowest common denominator, so I'm going to say here LCD. So for the example that I use here, the LCD was 5. Okay, we just wanted to find a way to get both of them to be 5. So what are we looking at lowest common denominators in terms of variables? This is where it gets a little bit tricky. Actually, not really. It's actually easier, if you notice. All we want is for the denominator to have x plus 1 as well as x minus 1 in this case over here, if you notice, because clearly we don't know what x plus 1 really is in numerical form, and we don't know what x minus 1 is in numerical form either, so therefore we're just going to use both, if that makes sense. So therefore we are only working with x plus 1 and we are only working with x minus 1, and we'll just multiply them together. Okay, then, because remember the operation, what you do at the top, you do at the bottom, but you're multiplying. So that's where this multiplication comes from. You'll notice that. And 1 can actually be written as 1 divided by 1, where the numerator is just 1. But we don't have to put that down. It's such a waste of time. Alright. Great. Now we need to actually do the thing. What you notice over here is that we are going to have 1 divided by x plus 1. Okay. And then we are going to have equals to, let's just say 1 divided by 1 minus 2x over x minus 1. And now we need to find a way for every single fraction to have this denominator. And how are we going to do that? Because remember, we want to make sure we're including both x plus 1 and x minus 1, so that is what we are going to do. So how are we going to make this denominator in that form over there? Clearly we already have x plus 1, so all we need to do is just take x plus 1 and multiply it by the remaining, which is x minus 1. So we're going to multiply it by x minus 1, but what we do at the bottom, we do at the top. So x minus 1 at the top as well. And now for the 1, clearly it's just 1. So we take the whole thing and then we just multiply it by 1 in the denominator here. But what you do at the bottom, you do at the top. So you also multiply the numerator with x plus 1 over x minus 1. And that does make sense, right? X plus 1 times x minus 1 divided by itself is going to give you 1. Because anything divided by itself gives us 1, except if it's 0 over 0. And then for the last one, notice we have x minus 1, but we're missing x plus 1. So what you do at the top, you do at the bottom, you do at the top. So multiply it by x plus 1, and then we obviously multiply by x plus 1 in the numerator. And now what are we going to get as an actual output? What you notice is that we are going to have x minus 1 divided by x plus 1 multiplied by x minus 1. Okay. And this is just going to be equal to what? X plus 1 multiplied by x minus 1 divided by x plus 1 multiplied by x minus 1. And clearly this does give us 1 because it's something divided by itself. And minus 2x multiplied by x plus 1 over x minus 1 multiplied by x plus 1. Okay. And then from here, what are we going to say? Okay. Every single denominator is exactly the same. Okay. And I'm going to ask you, I know it's possible that we can just cancel every single denominator. That's what your teachers tell you. They say if all the denominators are the same, they fall away. But why do they fall away? Well, think about this. If I give you the following equation, right? If I say x over 3 equals to 5 over 3 minus 4 over 3, what is in the denominator? Your teacher will tell you, okay, you can just cancel these out and then solve for x. But another way we can look at it is if we multiply both sides by the denominator. Notice that clearly what we are going to get is that the 3 goes in here, and we are going to get what? 3 multiplied by x over 3, which is equal to, and then obviously this 3 here is going to multiply into both the terms, and then what we're going to get is 3 multiplied by 5 over 3, sorry, and then we are going to have minus 3 multiplied by 4 over 3. And what do you notice? What we notice is that the 3's can cancel in every single one of these terms. And what are we left with? We obviously left with 1 in the denominator, and anything divided by 1 stays the same. So it's x is equal to 5, which is remaining over here. Notice 5 is remaining, and 4 is remaining, and x is remaining. So this is 5 minus 4, which is equal to 1. Or in a way that you can understand it, x is equal to 1. And it makes sense in this case over here. Okay, so that is essentially what we're doing. All we're doing is just multiplying both sides by the lowest common denominator. So I multiply this side by the LCD, and I multiply this side by the LCD. Okay, CD. And therefore, obviously the LCDs will cancel with each other over here because the LCD can go into both those terms. I don't want to just tell you straight off that you can just make them fall away. That's like the easiest part. Otherwise, if you just don't want to do mathematics further on, then it really doesn't matter. But I would still recommend that this is important to know. Okay. And then what do you notice? Now we're left with x minus 1. All the numerators are now left x minus 1 into x plus 1 multiplied by x minus 1 minus 2x into x plus 1. And then what are we left with? All we need to do is just multiply in the brackets now. So x minus 1 is equal to, sorry about that, x minus 1 is equal to, we use FOIL method, so x times x, which is x squared. Now the outer, it's going to be minus x plus x, and it's going to be minus 1. And then we say negative, so it's going to be minus 2x multiplied by x, which is just going to be, I think it would probably be best to say over here, we're going to take negative 2x and we're going to multiply it into each one, and we're going to see the outputs. Okay, so there we go. So what are we left over here? Negative 2x times x is just going to be minus 2x squared, and then negative 2x times 1, which is just minus 2x. Okay. And now from here, what we notice is that we are going to have x minus 1. We can actually like cancel out like terms from here. So notice that the minus x plus x cancel each other out. And then we have x squared, so 1x squared minus 2x squared, which is just going to be equal to minus x squared. And then we have minus 2x minus 1. The minus 2x and the minus 1 are also left. And remember that we have an equation, and if we want to solve quadratic equations, we need to make sure that one side is equal to 0 and the other side has variables. So let's take, since there's a negative x squared, let's take everything to that side. So therefore, we take the negative x squared over, it's going to be positive x squared, and then we are going to have, well, I guess let me write it like this. We know it's x minus 1, but then we take over the negative x squared, it's going to be positive x squared. Take over the negative 2x, it's going to be positive 2x. Take over the negative 1, it's going to be plus 1. And this is equal to 0, because we just emptied the one side. And look for common factors, okay? You can see x is on its own. Actually, it's not on its own. It's 1x plus 2x. So that's just 3x. But we also left with positive x squared. So it's x squared plus 2x. And then we have negative 1 plus 1, which is just 0. So therefore we're left with x squared plus 3x equals 0. And notice that it's not a difference of two squares. There's not anything else. We can break it out into x times x plus 3 times x, where the common factor is going to be x. So we take out x as a common factor, we're left with x and 3, so it's x plus 3. And then notice we have x multiplied by x plus 3, and therefore, this implies to us that, this is a therefore sign, by the way. I don't know why I did that. We have x is equal to 0, or we have x plus 3, which is equal to 0, which obviously means that x is equal to negative 3 for this one. Okay. There we go. There's your final answers for this question. Just take note of that. And I just realized something as well. You always need to check your answers. Notice that we have x equals 0 and x equals negative 3. If we plug in 0, we need to look at the denominators. The denominators originally were x plus 1 and x minus 1. And notice that if x was equal to negative 1, then it will be undefined. Okay? And then if x is equal to positive 1, it will also be undefined. Because remember, the denominator cannot be equal to 0. So if we have x equals negative 1 or x equals 1, that is when we have to rule out that answer. But clearly, that is not in our solution set. We don't have that answer. So therefore, this will be our final answers. Okay, let's go to one more example, and then we should call it a day. And it should be easier from here. Okay, so I know this one is a very simple one, because you have x squared minus 1 over x plus 1 equals to 2. But for example purposes, let's just use our method that we know. So let's look at the lowest common denominator. Okay, notice that we have x plus 1. What else do we have? Nothing. Okay, so x plus 1 is our LCD. Okay, now we need to start. So x squared minus 1 divided by x plus 1 is also equal to 2 over 1. Remember, right? Everything is a fraction. Okay. Now clearly, how are we going to get x plus 1 on this side over here? Because clearly we have it on this side. So we're going to just take what we do at the bottom, multiply by x plus 1. We do at the top, multiply by x plus 1 on the top as well. And therefore, what we have is going to be x squared minus 1 divided by x plus 1 is just going to be equal to 2 multiplied by x plus 1. Sorry about that. X plus 1 divided by 1 times x plus 1, which is just x plus 1. So therefore, what this implies to us is that we can now multiply both sides. So multiply this side by the LCD, and we can also multiply this side by the LCD. Or like the other teachers always say, cancel out the denominators, but I don't like that. That rule feels illegal, and I'm going to jail those teachers. Okay, I'm not actually going to do that, but like, I low-key feel like doing that. But yeah, we multiply both sides, and then they cancel with each other. So it will look something like this. Okay. And then we're left with x squared minus 1 equals 2. And then we have 2 into x plus 1. Okay. I know we could have done an easier method, but for example purposes, it's best to get used to this, okay? Alright. And then from here, x squared minus 1 equals, we just multiply the 2 into the bracket. So 2 times x is just 2x, and 2 times 1 is just positive 2. And then this implies to us that we have, we can actually just take everything on this side, because why? We have a positive coefficient for our x squared. Take all the other stuff over. We have x squared minus, so positive 2x goes over as minus 2x, positive 2 goes over as minus 2, but we have minus 1, so we just took this part over, and this is equal to 0 because we took over everything to the other side. Okay, and now we just have x squared minus 2x, minus 2 minus 1 is just minus 3, so equals to 0, and we can take our common factors. Now notice for our common factors, we have x multiplied by x, and we have 1 times 3. 3 is a prime number, so you can't have any other factors. So we do our brackets. So we have x on this side, we have x on this side, 1 and 3, so 1 and 3 over here. The highest sign gets the negative, so it's 3 gets the negative. Negative, the remaining sign multiplies with the first operation, negative and a negative gives you a positive for the remaining. And then equals to 0. And then therefore, what this implies to us is that x plus 1 is either equal to 0 or x minus 3 is equal to 0. And then obviously from here, x can be equal to negative 1 or x is equal to 3. But we're not done yet. We need to check our restrictions. The fraction that we had was x plus 1, right? And we need to note that for that denominator, our x values that we cannot have is when x is equal to negative 1. Because if x is equal to negative 1, then therefore we will have an asymptote in a function. If you want to know how to get these from complex, complicated ones, you'll just say x plus 1 equals 0. That is when it's undefined because the denominator is equal to 0. Then therefore that implies to us we're going to have x equals negative 1. That's how you can find it. So do we have x equals negative 1? Yes, we do. So therefore, we have to exclude it by putting a stripe in the equal sign. So x cannot be equal to negative 1. Therefore, the answer is x equals 3. So that will be equations with fractions.